just x. And if I take out the x, what would I be left with? Okay. Now let's look at the next two terms. 2x and negative 10. What do they have in common? 2. So if I factor out a positive 2, what would I be left with?
X minus 5.
Now I have an expression where I now have two common factors. That factor itself being an expression. I can take out an x minus 5 from each term, and what would I be left with?
2x.
Not 2x, what am I left with here? And then here, the plus 2. So I went from having 4 terms to 2 terms through grouping down to 1 term, because this is actually just 1 term, because it's a product of expressions. So again, if we look at B, the 6, the 9, and the 3, I can pull something common out of each of those. But because that 2 is stuck in there, I can't pull the same thing out of all of them. So grouping is really good when you can't pull the same thing out of each expression and you have an even number of expressions. So I wouldn't try grouping if I only had 3 terms. I would try grouping if I had 4 terms, maybe if I had 6 terms. So what is common to 6y squared and 9y? And what would that leave me with?
2y.
What do the next 2 terms have in common?
They're the same. The 2y plus 3.
These 2 are the same, but I have to be able to still pull something else.
Just take a 1 out.
I can take a 1 out. If they don't have anything in common, they always have a 1. 1 is always common, it just doesn't change it. So if I take out the 1, I'm still left with the same expression that I had before. But now I have 2 terms. That 2y plus 3 is common to each, which leaves me with the 3y plus 1 as a leftover. So the following page has a flow chart, or a tree diagram, or it has a visual of how I could factor polynomial expressions. So the first thing, we start off by looking for a common factor. Can I pull the same thing out of each term? So try that first, okay? Once you've done that, your next step basically goes with the number of terms that the expression has. If you have 2 terms, check to see if it's a difference of squares. So you look for that difference, and then you make sure that the 2 terms can be square rooted, that they are square numbers. If you have 4 terms, try grouping them in groups of 2. That's like the last class example we just finished. If we have 3 terms, that's where you have like an ax squared plus bx plus c, when you take out that common factor. I can factor by inspection or by decomposition. And like I said, we'll look at decomposition next class. Once you have done all of those and you get that final answer, make sure that you can't factor any further. So I'll show you what that means in the next example. So we look at A. 36 and 9, x squared. Do they have a common factor? Can I divide 36 and 9 by the same number? Divide them both by 9. So if I divide them both by 9, what am I left with? Okay. It is possible to factor expressions where the x is at the end. Leave it in this way. 2 terms. Is this a difference of squares? It has a different sign. Can I take the square root of 4? Can I take the square root of x squared? Okay, so if I take the square root of 4, I get 2 minus x and 2 plus x. And that's going to give me that 4 that I need here and that negative x squared that I need there. So I just leave it exactly as it is. If the constant term is first, I leave the constant term first. So with b, the same thing. I'm not going to rearrange this. I'm going to leave this exactly as it is. But when I do my product and sum chart, it's 2 numbers that add to 3 and multiply, it's actually to a negative 28 because of this negative right here. It's going to impact that 28. So 2 numbers that multiply to negative 28 and add to a positive 3. Now when I go to put these into my binomials, my 28 was positive, so that means that my 7 and my 4, even though this was a negative 4, when I write them in, I have to put them as being both positive. Otherwise, I'm not going to get that positive 28 that I need. My x is what has to be negative. So one of these has to be a positive and one has to be a negative. How do I figure out which one? Well, I look for the one that's going to give me the negative 4x. If I multiply this together, I want this to be a positive 7x. And when I multiply these two together, I want that to be a negative 4x. Okay. The example that I can think of where you might have to do further factoring would be this one. A squared minus 16. It's a difference of squares. If I go to factor this difference of squares, I get, or actually not a squared. A to the power of 4. So when I go to factor this, what would I get?
A squared minus 4, A squared plus 4.
And what can you tell me about a squared minus 4? It's another difference of squares. So I have to factor this one again, and what do I get when I factor this one?
A minus 2.
And then I have the a squared plus 4. That would be my final answer. So that's an example of what I mean by always checking to see if you can factor the factor. Okay? So then the questions. 2 and 3 have a lot of factoring, well, not a lot, but they have several factoring questions, which is, it's practice. That's how we get better at factoring. We just keep practicing different factoring questions. And then 6, 7, 8, 9, and 12 are multiple and numerical response.